Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of probability distribution for discrete random variable. So here we have x, and x here is a discrete random variable. Therefore, the function given by this one, so this is the notation fx, and it tells you that it's looking for probability that our random variable x here takes a specific value of x, okay? And this is called the probability distribution of x, and the name probability distribution is pretty much a general name. So the idea of a probability distribution is simple, really. So what it does is it tells you the probabilities of getting different possible outcomes for a given experiment. So basically that is what probability distribution is. And if x is a discrete random variable, another name for probability distribution is what we call the probability mass function. So PMF is quite often seen in some standard reference books. So we can also call this specifically as probability mass function. So here is PMF, okay? And a probability distribution, or PMF, because we are talking in the case of discrete random variable, well, it should satisfy the following conditions. And the first one here is this, where basically it says that probability of getting the value of specific x here should be non-negative. Greater or equal to 0 means it should be non-negative. The lowest value should be 0, and the highest value should be 1. We're talking about probability, yes. And we have learned that probability should be between 0 and 1. And if you sum up, so this notation here means you have to add all the probabilities related to the values of possible x here. So if you add all the probabilities related to that, then the sum of it should be equal to 1. And these are the two conditions that a function should satisfy in order to be called probability distribution, or PMF. Now, probability distribution, or if you want to be specific, PMF, because we are talking about discrete random variable here, well, it can be represented in various ways. For example, you can write it in terms of equation. You can write it or present it using a table or a graph, and we're going to look at this later on. And well, based on the next example that you will see later, which option do you think is most easy to be constructed? Well, that is for you to figure out later, okay? Right, let's move on to example 3.3. Now, we have a function given here, and we have to investigate whether the function given can be considered as a probability distribution of a discrete random variable. So as I've said just now, if this is a probability distribution, it has to satisfy these two conditions given here. Okay, so that's what we're going to do first. We are going to check whether the two conditions are satisfied, and let me just write down the function here. So we have fx x plus 2 over 25, and we're going to check each and every single value that is given here. So if x is equal to 1, so I'm going to check if x is equal to 1, then we've got f1, just substitute 1 into x, okay? So we have 3 over 25. When x is equal to 2, f2 is going to be, well, substitute 2 into this, so you will get 4 over 25. And in a similar manner, you are going to just continue doing the rest of the values given here. X is equal to 3, so f3 is 5 over 25, and then x is equal to 4, so we've got this one is 6 over 25, and finally x is equal to 5. Therefore we've got this function here valued at 7 over 25, and clearly you can see that all these values here are non-negative. So therefore the first condition here is satisfied, okay, because all the values of fx here is greater than or equal to 0. So that is the statement that you can write down related to condition 1. And for condition 2, you have to add up all the values of fx and see whether the result is equal to 1. So for the second condition, you have to add all these values, so they are all over 25, and therefore we've got 3 plus 4 7, 7 plus 5 12, 12 plus 6 18, 18 plus 7 25, so 25 over 25, which is equal to 1. Therefore once you add all these values, you will get the result equal to 1, and you can say that it satisfies this second condition here, and therefore we can say that this function is indeed a probability distribution of a discrete random variable. Okay, so if it is, now the next question is asking you to demonstrate other ways of representing the probability distribution. Now other ways that we've talked about is in terms of equation. So equation is already given here, so this is a probability distribution in terms of equation. There's another way of representing the probability distribution, which is by using a table. So what we need to do is we're just going to create a table. So we've got the values of x here, and we're going to list down all the possible values, which is 1 2 3 4 and 5, and we're just going to list down fx. Okay, so remember, what is the meaning of this? Well, the meaning of this is what is the probability of our random variable x taking a specific value of this one here. So this value can be 1 2 3 4 5. Okay, therefore we can list down the results that we've got over here. So it is 3 over 25, 4 over 25, 5 over 25, 6, and finally 7 over 25. So this is how we can represent the probability distribution using table. Okay, maybe next is we're going to try and represent it using a graph. So how does it look like? I'm just going to erase this part here. Okay, all right, there you go. So we're going to start by having our axis drawn. So this is the y-axis and this is the x-axis. So x, and we've got like 1, 2, 3, 4, 5. Okay, so we've got 1, 2, 3, 4, 5. Next, we can consider having this scale 1, 2, 3, 4, 5, 6, 7, maybe 8. So this is actually for fx. So this is we can label it as 1 over 25. This one is 2 over 25, 3 over 25, 4, 5, 6, 7, maybe 8 if you want to continue further up a bit. Next, for x equals to 1, the value is 3 over 25. So this is the value right here, which you can plot for x equals to 1, and we've got like straight line coming downwards. Okay, so that's the value. Next, for this one, the value is 4 over 25, so maybe somewhere here. Okay, this one 5 over 25, so maybe somewhere there. This one is 6 over 25, maybe somewhere here. Okay, and finally for this one is 7 over 25. Okay, right, so there you go. We've covered 3 different ways of representing probability distribution, or in this case, if you want to be specific, we can say probability mass function, because we are right now dealing with a discrete random variable. How do we know that this is discrete? Because the values of x can only take whole numbers such as 1, 2, 3, 4, and 5. So definitely this is related to a discrete random variable. And we have covered this part here. How can it be represented in various ways? So there are 3 different ways: equation, table, and graph. Alright, I think that's all for now. Thank you very much for watching.